Right, so the first one, 5 to the power of minus 1, I had to say would be 1 over 5 to the power of positive 1. Then at B, minus 6 to the power of minus 1 will be minus 1 over 6 because I moved that to the bottom of the fraction. Put that away, thank you. Right, then at C, minus 8 to the power of minus 1. Remember that to the power of minus 1 applies to the whole bracket. So you will see that initially I moved that whole thing to the bottom and it becomes to the power of positive 1. But because there was nothing else at the bottom, you could have also written it without the brackets. Okay. Any questions there? Right, then 3 to the power of minus 2. I'm going to take that to the bottom part of the fraction. So it becomes 1 over 3 to the power of positive 2. Now, this 3 to the power of 2 is the same as 1 over 9. Power of the EMS. Right, can I skip? I'm not hearing anyone complain, so I can skip. Right, number 2 of E. Minus 2 to the power of minus 3. Now, I want to make that exponent positive, so I'm going to move it to the bottom part of the fraction. So it becomes 1 over minus 2 to the power of 3. Now, over here, the brackets were important. Now that... Ooh. No, it's a yawn. It's not a... That to the power of 3. Baie dankie. Julle moet my maar bless. That to the power of 3 applies to both the negative and the 2. Right? And a negative times a negative times a negative gives me a negative. And 2 to the power of 3 is 8. Yes. 5. Yeah. Sorry? That exponent, like this bottom part. Oh, yeah. Okay, so this, that minus 2 to the power of 3 is actually minus 2 multiplied with itself 3 times. Okay, does that answer your question? Okay. This is what 3 o'clock looks like.
En je brein eet oxygen inside it.
Nee, dis omdat ek 3 uur gaan slaap het. Okay, so F. At F, minus 4 to the power of minus 3. Now that to the power of minus 3 only applies to the 4. No, it's got nothing to do with it negative. So I put the negative in the front. And then I moved this to the bottom part of my fraction. And then I've got 1 over 4 to the power 3. And 4 to the power 3 will give me 64.
Ma'am, we should take a break. Yes, ma'am. Please keep them.
Any questions?
No, ma'am.
Can I skip?
Ma'am, they have to.
Nice. Why say you? Why say you?
No, ma'am.
Can I skip? Can I skip?
Yes, ma'am.
Fatsie? The oldest is John Alfred, and then, yes, a boy, and then a girl, Ronelle, and then a boy. Ronelle is grade 4. And then a boy, Sebastian, and then a girl again, Tialise.
And how old is the oldest one?
Mine is 1.
12.
Nine. Number 1.
Right, okay, that's enough? No. Right, so 2a. When we have brackets, a half to the power of minus 1. Now remember that minus 1 applies to everything inside the bracket. So it's the same as 1 to the power of minus 1 over 2 to the power of minus 1. Now to make them positive, I'm going to move them to the other side of the fraction. So if this one moves to the top, it becomes 2 to the power of positive 1, but I don't have to write that one. If this one moves to the bottom, it becomes 1 to the power of positive 1. So just 1. And 2 over 1 is the same as 2. Any questions there? Okay, at B, same thing. Remember, you could also, I think it's in the next slide. Yeah, in the next slide, I'll show you that. That to the power of minus 1 applies to both the 2 and the 3, so that's what I did here. Then to make them positive, I switched it to the other side of the fraction, and that's why it becomes 3 over 2. Okay. Yeah. Olives. You guys are interested in everything that's not math related, huh? Sorry? Thanks. I do. Fine. Right, can I skip? Can I skip? Julle, ek record al hierdie strooi wat julle praat, né? Right. Then at C, 3 over 5, I like Kentucky, to the power of minus 1. Okay. That to the power of minus 1 applies to everything inside that bracket. So to make the exponents positive, we switch them around, and that's why I end with 5 over 3. Okay, at D. Cool. Let's quickly finish our work, and then I'll stop the recording, and then we can chat about A and E. But we first finish our work. Right. So, guys, now I need silence. Okay, so that to the power of minus 2 applies to everything. So that's why I say 1 to the power of minus 2 over 3 to the power of minus 2. Then I want to make the exponents positive, so I'm going to move it to the other side of the fraction. And that's how I get to 3 to the power of 2 over 1 to the power of 2. And that's the same as 9 over 1, which is just 9. Now, if you wanted a bit of a shortcut, you could have a look at what I did here, the blue. I said that to make that exponent a positive, to get to this, all I did is I took that fraction and I switched it around. So can you see instead of 1 over 3, I now have 3 over 1. Do you guys see that?
Yes, sir.
And now I apply that to the power of 2 to both the 3 and to the 1. So 3 to the power of 2 will give me 9, and 1 to the power of 2 will give me 1. But we don't write it as 9 over 1. We can just say 9. Okay. Can I skip? Yeah, is it Meg? Yeah? Where? Yeah, when it is like over here, 5 to the power of 1. I'm now here, no? Okay, so 5 to the power of 1. You can write the 1, but if there's nothing written there, we also assume that it's to the power of 1. So that's why I'm saying you could actually have left it out as well. Wait, give me a number. Yes. Over here, yeah? Yes? Yeah, good. Yeah? No, 6 over 1 and 1 over 6 is different things. Now have a look on the board. You copied wrong. Okay. Okay, so you've got it now. Yeah. It's not wrong. Yes? Honor. Okay, right. E and F. Let's have a look. So I wanted to change this exponent to a positive. So I'm taking it to the top. which means it would be 2 to the power of positive 2, and that is actually 4. You guys at the back, yellow driekies. You weren't with them now, but a lot of the others. You?
3 small people.
The 3 of you back there. Huh? Yellow driekies. You're constantly talking, ne? Right. Okay, over here, that to the power of minus 3 applies to everything inside that bracket. So that's why I say 3 to the power of minus 3 and 4 to the power of minus 3. Now I want to make them positive. So I'm going to switch it to the other side of the fraction. So now it becomes 4 to the power of positive 3 over 3 to the power of positive 3. And then that simplified. The 4 to the power of 3 gave me the 64. And then 3 to the power 3 is the 27. And it couldn't simplify any further than that. How do I know that? I put it in my calculator and say equal. Right? Right, can I skip? Nilan, tell me when you're done. You're not Dylan.
It was funny.
Okay, you're done. Okay, let's look at 3. Now at number 3, you had to be very careful. Yeah, they actually wanted you to use what we've been taught from law 1 and law 2. Right? So at 3a, they say 2 to the power of 5 times 2 to the power of negative 3. Now, can you see base is the same for both? And we are multiplying. So what do we then do with exponents? We're going to add. So that's why I say 2, so base stays the same, eh? Base stays 2, and then to the power of 5 plus that negative 3. And that will become 2 to the power of 5 minus 3, which gives me 2. And 2 to the power of 2 is 4. But if you maybe stopped there, I would still take it as correct. Okay? Remember, I write every single step because each one of you thinks differently. So I want you all to know exactly what you would and could have done. Okay, but you don't have to in the test. Okay, at B, 4 to the power 3 divided by 4 to the power of minus 4. So base here is the same. They both have a base of 4. And we are dividing. Waarom is jy besig? Geef vir my die briefie.
Ma'am, don't read out loud, ma'am. Don't read out loud. No, ma'am, don't. Ma'am, it's not. Ma'am, it is something deep.
I'll post it on the WhatsApp group. You can sit down, thank you. Right. Right. You guys, quiet? Okay, so because base is the same for both and we are dividing, what do I do with exponents? I'm going to subtract. Have a look. I'm showing you that I take the first exponent minus the second exponent. Now these two signs are both negative, and that will mean that it will become 3 plus 4. And 3 plus 4 gives me that 7. And 4 to the power of 7 will be 16,384. Okay. Can I skip? Right. Number 2a. 2c. 3c, sorry. Okay, over here, we are multiplying. But there were coefficients as well. So what I did is I first multiply these coefficients. 2 times 3 gave me that 6. Then, look at all the a's. I've got a to the power of minus 2, a to the power of 3, and a to the power of 0. Now, because they all have the same base and we are multiplying, I'm going to add those exponents. So base stays a And here you can see that I'm adding them all. Now, if I add it up, that's going to give me 1. But again, you'll see I wrote that in yellow. So you could have just said 6a. You don't have to say 6a to the power 1. Sorry, 6? I can't, wait. No. Remember we said right in the beginning, we said base must be the same and we multiply. Then we're going to add exponents, but remember, base stays the same. We only add the exponent. And I explained it to you guys like this. Say, let's say it was a to the power of 2 times a to the power of 3. Then I said this is actually a times a. And that will be a times a times a. Okay. So if we now look at how many a's there are, stays a to the power of 5. So can you see base was a and it stays a. Okay. Okay. Any other questions? Now at number 4. Number 4, you have to see that we have a plus sign there, which means I can't use law 1 and I can't use law 2. Okay? So I had to go and simplify each of those terms separately, meaning 2 to the power of minus 2 will become 1 over 2 to the power of 2, and that is actually a quarter. Now we simplify the second term on its own. 2 to the power of minus 3 is the same as 1 over 2 to the power of positive 3, and that's the same as 1 over 8. Yeah. Okay, I'm going to tell you now. So up until here, you had to show me all your steps. No? But once I get there, then you can actually use your calculator. No? And get to this. How I got 3 over 8 is this 1 over 4. I had to make that denominator 8 as well. No? So 1 over 4 is the same as 2 over 8. No? If I multiply with 2 at the top and the bottom. So 2 over 8. Now 2 over 8 plus 1 over 8 will give me that 3 over 8. Okay. Yeah? Remember, it's normal addition, eh?
Oh, yeah.
Okay. Right, can I skip? Right, at B. 4 to the power of 0. Remember, anything to the power of 0 is 1. Okay, and 4 to the power of minus 1. To make that exponent positive, I'm going to say 1 over 4 to the power of 1. No, have a look. It's got a negative exponent. Yeah, but remember, pass me. 4 to the power of minus 1, it actually looks like this. No? Sorry? Oh, there. Okay, that's it. Okay, so to make this exponent positive, I'm going to take that and move it to the bottom. Right? That's why I get 1 over 4 to the power of positive 1. But you don't have to write the positive 1. You can just say 1 over 4. Does it make sense if you saw? Wat's fout? Laat hom julle vorm. Huh? Right, so 1 minus a quarter will then give you 3 quarters. Okay, and then the last one, 3 to the power of minus 2. Make that exponent positive, so I move it to the bottom. It becomes 1 over 3 to the power of 2. Over here, to make that exponent positive, I'm going to move it to the top. And then it becomes 4 to the power of positive 2, and it's actually over 1. But do we have to write over 1? No. So that's why I just write it like this. Then 15 to the power of 0 will be 1. Remember, anything to the power of 0 is 1. Okay, so now I can simplify. That 1 over 3 to the power of 2 is the same as 1 over 9. 4 squared is 16. And now if I add all of these up, I'm going to get 7 and 1/9. Or if you wrote it as an improper fraction, 64 over 9. You guys good? Can I skip? Why are you doing MS? What were you busy with now? Yeah. What was the book that you just closed and put away?
Just a book.
What book was it? So why are you doing MS? What have you got after this? Who's your teacher?
Zanakum, Miss Zanakum, Miss Zanakum, they upstairs.
Don't worry, I'll ask on the group. People, if you do homework in my class, I'm going to let your teacher know. Right, can I skip? This is math period, not an off period. Right. So next up, we are doing different bases, but same exponents. Meaning, 2 to the power 3 times 3 to the power 3. Can you see my base is 2 and the other one, my base is 3. So the bases are different. But they are both to the power of 3. Okay, now, just before I show you how to do that, please have a look here. I said very important. This rule we can only use when we are multiplying and dividing. So when it's plus or minus, you can't. Okay? Yeah. NB only at multiplication or division. Do you guys understand? So you can only use this at multiplication or division. Okay, right. So I'm first going to show you the long method. So that 2 to the power 3 would actually be 2 times 2 times 2. No. Okay, then times. The 3 to the power 3 will be 3 times 3 times 3. No. Okay, so what I'm going to do now is I'm going to use exactly that, but I'm going to group them a bit different. I'm going to shuffle the numbers around. So instead of saying 2 times 2 times 2, I'm first going to say, let's take a 2 and I multiply it with one of the 3s. Come on. Then, let's take one of the second 2s and multiply that with one of the second 3s. Yeah? No, wait. I'm working towards something, so bear with me. No? Then, I take the third 2 and multiply that with the third 3. So I still have 2 times 2 times 2, and I still have 3 times 3 times 3. Can you see I just shuffled them around? Okay, now if you look at the orange, that's going to give you, the 2 times 3 is going to give me 6. Okay? The blue, 2 times 3 is going to give me 6. Ach man, jy weet wat ek bedoel. Then the green, 2 times 3 is going to give me 6. And isn't that the same as 6 to the power of 3? No. Now, have a look. What do you see? My exponent is 3. The exponent of these were also 3. So can you see the exponent stays the same? But how did we get to that 6? We said 2 times 3. No. So 2 times 3. No, I am showing you long method to make you see how we actually get to this rule. No? Right. So let me just finish my sentence. Obviously, you guys do not want to use this long method that we just did. No? So to cut to the short method, we're going to say 2 times 3, and that to the power of 6. And then after that, you get to 6 to the power of 3. No? Yes. Yeah? No. So we want to save time, so we use the short method. Okay, so who wants to guess, yeah? I'm going to show you more. Is that what you want to ask? You're not completely... No, so all you're going to write for me is that. Only, nee, jy kan net lekker sien. You're only going to... Nee man. You guys are only going to give me that. You're just going to write 2 things. I'm going to show you now in the next few examples exactly how I want it to be written. Okay, so have a look at the bottom one. So a to the power of n times b to the power of n. Can you see bases are the same? Okay? The exponents are the same. But the bases are different. So what I could say is multiply the bases. So a times b, which will actually just be ab. Right? And then to the power of n. Can you see the short method? Right? No. Above is the long method. But you know net oor gekla het and now I show the short one and then you say, oh, isn't there a longer method? I just did. Yeah. Okay. Let me skip to the next slide and then. Okay. Did you guys all copy? Are you done? Right, let's look at the next one. We said it can be used at multiplication and division. So let's just do 2.